Hello and welcome to this Istio Overview video. My name is Rob Bagby. I'm an engineer at Microsoft, and over the next 20 minutes or so I'm going to be talking to you about Istio and service meshes and illustrating how you can take advantage of Istio to solve a lot of the challenges that you're going to have when working in a microservices architecture. So I kind of like to start off with why you should care about Istio. So if you work with, you're building born in the cloud or cloud native applications or microservices applications, it doesn't matter what you call them, and you're working with Kubernetes, you probably have the following concerns once things are running in Kubernetes: security, policy management, resiliency of your application, advanced routing for things like canary deployments, visibility into your application as a whole, and developer productivity. So if those are concerns for you, then stay tuned, because Istio is going to be a very nice solution for you to solve a lot of these challenges, and hopefully I can illustrate that here with this visual. So I like to talk about containerized solutions kind of in terms of layers, starting with the bottom layer, which are just containers themselves. Containers themselves have a couple attributes that give you some very nice benefits. The fact that they encapsulate their dependencies means that you know that a containerized application is going to run anywhere that has a container engine on it. And so that gives you the ability or the possibility of getting this what's referred to as a high application density, because you no longer need to have your dependencies running on servers or virtual machines. They're encapsulated inside of the container themselves. You can have Java apps sitting right next to Python apps, sitting right next to .NET Core apps. Makes it very easy for you to get these that application density. You also no longer have that works on my machine or it ran in staging and not in production. That's a very powerful model. You also, because they're immutable, you get this transparency, so you know what's running. Now, I mentioned that you have the ability to get application density, but it doesn't actually, the containers don't actually provide that. It's actually the role of the orchestrator or the scheduler that's going to allow you to get application density. They're going to allow you to implement it. You're going to deploy out an application topology, and then the orchestrator or the scheduler is then going to ensure that that topology is up and running. And it's going to deploy your services running on those nodes, and you'll eventually get to that density you wanted. You also get these high-level things like beyond scheduling, you get monitoring and configuration management, cluster management, networking, and service discovery and load balancing. However, a lot of people believe that once their end goal is getting running in, say, Kubernetes, but they soon figure out that once they've got their service running up, their services running up in Kubernetes, there's still a host of other challenges that await you. And I've kind of put them in these little in these little hexagons up here. So you've got higher level routing needs. How are you going to trace through your application? You've got resiliency, because you know that services are going to have failures and you're going to have timeouts. How are you going to handle that? You've got monitoring, storage, image signing. All of these challenges still await you, and there are a whole host of projects that you have to use in order to get all of these. You don't get all of these. You can't just buy a platform that provides all of this to you. OpenShift for Red Hat attempts to be that, but when you're just running on a plain vanilla Kubernetes cluster, you have to kind of craft these up yourself. So you might be pulling from different projects and buying some solutions and tying them all together to build your platform. Now, the reason why I'm bringing this up here is that Istio tends to address a lot of the challenges that you have. And so as we walk through the rest of this presentation, I'll hopefully illustrate that to you. So what is Istio itself? Well, it's a service mesh. And if you've heard that, but you're not quite sure what it is, I kind of scoured the internet and tried to find the best description of what a service mesh is. And really the best I could find is service meshes attempt to make service communication a first-class citizen. So you've got this dedicated infrastructure for handling this service-to-service communication that happens at layer 7, and this is all pulled out in a thing that is a first-class citizen. So what do service meshes address? Well, we kind of were introduced to that. Routing between services, security between services, policy management, who can talk to whom, resilience. So you can do retries and fault timeout injection and testing that, and visibility, monitoring, and tracing. So how is this architected? Well, when service meshes first started to come about, a lot of times you would see them implemented as client libraries. But this brought about a bunch of challenges. So think about if you were maybe working with some Java components and you built your service communication logic all inside of Java, and now you had started to get some Python or Ruby or whatever languages you're working in. You would obviously have to port that over to another language. Assuming you could get a direct port to all the languages that you worked with, how do you convince every team to use that client library? That's another challenge. And then the third challenge is when you go to version up and you've got to make some changes to that client library, you've then got to go back to all of the consumers and ensure that they're using the latest version of that client library. To that end, a new pattern emerged called the sidecar pattern, which is actually how Istio is architected. So, what is the sidecar pattern? Well, if you've ever kind of read about pods in Kubernetes, you probably read something similar to the pods can contain one or more containers. Typically, a pod has one container, but there are use cases for pods having additional containers. And those use cases are you typically have another container that's providing services to the main container within your pod. Well, that's exactly what the sidecar pattern is. Essentially, we inject a sidecar. In this case, it's a proxy that intercepts every inbound and outbound call from the services. And by doing that, you're able to externalize the logic, all of this service-to-service communication logic, into that sidecar. So here's a nice visual. You've got a couple pods that have service A and service B that want to communicate with them, and they may also want to communicate with external services. And so any outgoing call from service A to service B is going to walk through its sidecar, which is then going to talk to the sidecar on service B, which is then going to communicate with service B. So that's essentially how Istio is architected, and the sidecar in Istio is something called Envoy proxy. And Envoy was written by Lyft, the ride-sharing company. And to date, as I understand it, the Envoy proxy over the last couple of years is handling over 1 million transactions per second. So it's a very battle-tested and battle-hardened proxy that Istio has chosen to use. I should also mention that Istio is really not one thing, but takes advantage of several projects that are available, Envoy being one of them. So again, the features of Istio: routing, security, policy management, resiliency, and visibility. And this is just really one way that I took a stab at trying to organize all of the features of Istio so I could walk through them. Obviously, some things kind of fall into multiple categories, but we'll walk through each of these and try and illustrate how they work. So let's start with routing. So Istio and routing, here's a nice visualization of how Istio and routing works. So assuming that you're somebody that wants to set up some sort of routing rules, maybe I want to direct all traffic to service X to version 1.1 or something like that. You're going to push that into a rules API. Now the rules API, Istio itself supports multiple platforms: Kubernetes, DCOS, Cloud Foundry, etc. So it has its own abstract model, and then it's got an adapter that will basically run the translation between each of those systems models and its own abstract model. Then there's an Envoy API. So the Envoy API is going to be essentially the gateway, or it's going to be the communication mechanism for each of those Envoy proxies. So each of those Envoy proxies is going to talk to the Envoy API, and they're going to have a local cache of all of the routing rules. So whenever something like service A wants to do a communication out, it's going to walk through its Envoy proxy, which has all of the routing rules inside of it. So here's an example of Istio routing with a canary. example. So we sent the routing rules down through the rules API and in the Envoy API. Each of our pods was able to talk to the Envoy API. So when service A is going to http:// service B, that Envoy proxy knows that I've told it that I want 5% of my traffic to go to version 2 and 95% of my traffic to go to version 1. This is kind of your vanilla canary example where you may want to try out a very small bit of the traffic that you have on a new feature just to make sure it works properly. Now, we don't have to do just a straight 5%. We could configure rules to say, hey, if specific users or specific IP ranges are trying to get to service B, then route those to version 2, but route everything out that's general traffic route to version 1. Really, the sky's the limit to you, and we'll show you an example of routing a specific user in the demo coming up. Now, before we jump into the demo, I want to walk you through book info. So when you install Istio, you're going to have samples directory is going to be created for you, or you'll bring that down when you download Istio. And inside of the samples is something called book info. And this is kind of a high level of what book info is. It's a very nice representation of a microservices world. It's basically an online bookseller app where you've got a product page and it calls into reviews. Now, reviews, depending upon which version of reviews you've deployed, either calls in and gets ratings or doesn't call and get ratings. So the version 1 doesn't call and get ratings at all. Version 2, we implemented the ratings functionality and we exposed them as black stars. Version 3, however, changed those to red stars. Okay, and now it's important to also note that each of these services is written in different languages. So this is a clear representation of, the kind of polyglot microservices approach. So you've got Python, our product page is written in Python, you've got the reviews is written in Java, the details are written in Ruby, and Node.js is used for the ratings. Now, if you go ahead and take a look, here, this is what it looks like when you've injected an Envoy proxy into each of those containers. And so instead of deploying a single pod per container, container per pod, we've also deployed out a proxy in each of those containers. So see, the product page has a proxy and reviews each have proxies, etc. And we're going to illustrate to you in just a moment how you can take advantage of those. We're also using the Ingress Envoy Ingress for requests from the outside world, and we'll see what that looks like and why you care about that in just a moment. But let's start with our demo on routing. Before we get started with the demo on routing, I wanted to show you how you can install Istio. So if you go to github.com, whack Istio releases, this is where all the releases are. And so if you want to get one of the latest releases, this is where you go. There's several ways you can install Istio via Helm or just running the YAML files yourself. I'm going to show you how to do it just running just deploying the YAML file. So I basically downloaded Istio 0.7.1 and I'm in the directory where that is. So I'm just going to change into cd into Istio 0.7.1. And then I'm going to go into install, and then you can see that I've got a bunch of directories here, and so I'm going to go ahead and run some deployment commands to just deploy out using kubectl create. So I'm going to back up one directory first, and then let's just go ahead and run our installs. So I'm just doing an apply, doing Istio auth, and it's going to go ahead and create all the cluster role bindings and custom resource definitions. If you're interested in understanding cluster roles and cluster role bindings, there's another video on RBAC that I've done earlier. But this is going to go ahead and create all of the assets we wanted, including installing Prometheus and Grafana, which we're going to see at the end, as well as Zipkin. So we'll see what all those do for us. But now we have Istio up and running, and we can move on to the next demo. If you created your cluster using ACS Engine like I did, given the guidance that I provided in an earlier video, you're going to run into a challenge when trying to deploy book info. And there's actually a an issue filed out on Istio, and the issue is that there's a security context deny admission controller, and so we need to remove that. And so I'm going to illustrate to you how to do that. So if you go into the portal and look in your IP address for your master, you can get the DNS name for your master. So I'm just going to copy that into the clipboard, and I'm going to go over here into my terminal, and I'm just going to do an SSH to whatever the name of your admin is on that master, and then just paste in the DNS to your master, and you can get in there after you enter the passphrase for your SSH key. And now what we need to do is we need to go into the etc Kubernetes manifest kube server .yaml. So I'm just going to go ahead and I'm going to paste that command in. We're just going to VI this file, and you can see that that's the file, etc Kubernetes manifest kube API server.yaml. And inside of here, we can see the security context deny is going to be somewhere right here. So we need to go in and get rid of that. So let's go over here, and then I'll delete that. And we're good to go. Now we need to restart kubelet, so I'll do systemctl. And we should be good to go. So with that, you can now actually move on to the next demo, where you're able to, or we'll show you how to take advantage of Istio with regard to routing. Okay, so for the routing demo, we're going to deploy book info, which we illustrated, kind of the high level what that looks like inside of the in the slides. The first thing I'm going to do is I'm going to deploy it, and then I'll show you the YAML file and show you all the services and etc. But it takes a little while to deploy, specifically so we can get the ingress controller in. So let's do that. So normally when you were going to deploy a YAML file, you would do kubectl create -f, and then we would do book info .yaml. But I mentioned we want to inject a sidecar into each of the pods. So you can either configure that to be done server side, which I haven't done, or you can do it manually using the istio-ctl. So I'm going to do that. So we're just going to say istio-ctl kube inject -f, and then we'll do bookinfo.yaml. And so this is going to go ahead and deploy all of our services as well as our pods, but it's going to inject the sidecar into each of our pods. And so we should be able to see all of that in just a minute. But while this thing's all deploying, let's go ahead and take a look at what's in the YAML file. So the first thing you can see is that if we go back to book info to the very top, you can see that we've got, here's our details for the product details. Here's the service that sits in front of our deployment. We just have one deployment for details. Then we've got our rating service that's sitting in front of our deployment. And then we've got, this is the interesting one, we've got a review service that's sitting in front of all of our version 1, version 2, and version 3. So we've got the reviews version 1, reviews version 2, and reviews version 3. Then we got our product page, which is kind of our root page that calls into the details as well as the ratings, and then we've got its deployment. Now notice this guy is not of type load balancer, so the service is a cluster IP. But then we've got an ingress. Then we've got Istio ingress deployed, and so you're going to be able to reach our product page by whack product page after we get the IP for our ingress. So we'll see what all this looks like in a second. Let's go back and take a look, and we'll also talk about why you might want to take advantage of an ingress controller versus a load balancer a little bit later as well. But let's go ahead and see if the ingress has been created. So let's do a Okay, get pods, we'll see the pods, and we'll see that we do have an ingress created, and we have a public IP address. So we can go ahead and take a look at our service. And so let's go into our browser, and let's go ahead and just paste in our ingress address, and we need to put in the product page. And we can see that we can get to our service. Now if we run this and we just refresh it a few times, take a look on the right, look at the book reviews. We're going to version 1, version 3, version 2, version 1, 3, 2, and we're getting all different calls into the different versions of our review service, which we might not want to have. So let's go ahead and take advantage of routing to force us to route to whatever our choices are. So let's go ahead and take a look and see what that might look like. So I'm going to open up back into code, and I'm going to take a look at this routing rule, which is basically, it's called route rule all v1. And what we're going to do is we're going to force any call that goes into ratings. So if the destination is ratings, we're going to force it to go to version 1, okay? And any thing that's going into details, we're also going to force that to version 1. And as well as for our reviews, we're forcing everything to go into version 1. So let's go ahead and deploy that. Let's go ahead and deploy this. And let's do k create -f, and let's do route rule all v1. It's going to create those 4 rules for me. And now if we go back into the browser and we take a look and we start to refresh this thing, version 1, version 1, version 1, version 1. It's going to stay at version 1 the entire time. So we've essentially defined the path for the reviews that we want to go to. Now, what if we wanted to route some users over to version 2? So we can look at that. Let's see how we can do that with routing as well. So let's go back into the code, and let's take a look at route rule reviews test v2. And so what we're going to do here is you're going to see for the destination of reviews, this is a precedence of 2. So the higher the precedence, they're going to get these rules are going to get looked at the higher the precedence. It's going to take precedent over the lower precedent rules. So it's going to say, hey, if the request headers cookie matches this regex, so basically if the user is JSON, route them to v2. If this doesn't hit, though, then everybody else is going to get routed to version 1. So let's go ahead and let's deploy this one. And that's going to be route rule, and it's going to be reviews test v2, and that's running. And then let's go into our browser again and take a look at the app. Now, if we go ahead and just refresh this a bunch of times, still we're all going to version 1. However, if I log in as JSON and sign in, JSON's going to go to version 2 each time. If I sign back out, back to version 1. So that gives you an idea of how you can do something like a canary deployment, saying, hey, I want to push this out onto the actual production servers, but I want to be able to test it, but I don't want the whole world to see it. You can also do things like IPs or IP ranges. So really the net is you can take a subset of your traffic and partition off who you want to see what, and you can take advantage of that. Let's take a look at one last routing option we have, and let's take a look at what maybe a sample canary deployment might look like. So you can see this is really a high-level example, but it'll give you a good idea of the power that you have with Istio. So what we're doing here is I'm saying this rule is going to take precedence over the version 2 rule we had out there, and what it's basically saying is that I want to set 75% of my traffic in aggregate over to version 1, and I want 25% of it over to version 3. So let's go ahead and run this one as well. So let's go into our terminal, and let's do kubectl create route rule reviews canary. And let's go back into the browser and take a look and see what we've got. So if I just refresh this a ton of times, we're going to be going between version 1 and version 3. So version 3. And if we ran this over and over again, over 100 times, 75% are going to get routed to one version and 25% are going to get routed to the other. So hopefully those demos have illustrated to you how you can take advantage of the advanced routing available in Istio. Let's jump back into the slides and take a look at some of the other features of Istio. The next feature we want to talk about with Istio is security. Specifically, we want to talk about mutual TLS authentication. So this diagram illustrates to you that each of those Envoy proxies is going to have a certificate mapped to it. So you're going to get automatic mutual TLS authentication in between each of your services. So all of that communication is going to be encrypted. What's not shown here is that each of our services has a strong identity running as a service account, and so we'll be able to do things like set up role-based access constraints based on the identity of those services, and you can avoid any challenges where something may be trying to act on your behalf or act as you, but because you know that strong identity and you can verify it, you know who you're talking to. The last thing to point out here is that Istio handles all of the key management and rotating the keys, so you don't have to handle all of that. So just out of the box, without making any changes to your code, you're able to get this secure communication between your services within your cluster, but you also know who you're talking to as well, and you don't have to handle any of the key management. The next thing I wanted to briefly talk about is policy management. Istio has a pluggable microservices policy layer and configuration API, and the list of things that are being supported are growing. You'll be able to do things like control Calico within Istio, so you'll be able to control network policy. You can do things like access controls, which we're going to see in a moment, rate limits, quotas, circuit breakers. So there's a lot to see here. What I thought I would do is just show you an RBAC policy implementation, and this is taken directly from the Kubernetes documentation. So what you see here at the top is a service role called service admin in the default namespace that really just allows full access to all services and all methods. Now down here, just below that, you've got a service role called products viewer, again in the default namespace, that really only allows you to call get and head on the products service. Now over to the right, you can see how we've bound the products viewer role over to really two subjects, to user alice@yahoo.com as well as to the reviews service. So this should give you a really good idea of how you can take advantage of once you have those strong identities for each of your services. Now you're able to use RBAC and able to enforce what those services are and are not able to do. The next set of Istio features I want to talk about surrounds resiliency. You can really think about resiliency from two angles. One, how do I add resilience into my services? So how can I ensure that I'm doing things like when I'm making a call to another service and it fails, how do I do retry? And how do I do retry properly so that I've got a back-off strategy so I'm not flooding myself? And also, how do I set request timeouts so that I don't sit and wait an indeterminate period of time when trying to make a call? The other side is, how do you test your application to ensure that it is resilient? So how do you do things like test by injecting faults for some services? So what's your application going to do if it's calling to a downstream service and that service returns a 404 or a 500? Or what's going to happen when one of your services it takes 20 seconds to return? What does your application do, and does it work properly? Istio allows you to handle both of those scenarios, where you're able to, because all traffic in and out is going through the Envoy proxy, you're able to inject faults, inject timeouts, but you're also able to set policies so that you can add a retry policy and make sure that I'm retrying 3 times, or I'm setting request timeouts and I'll only wait for 3 seconds in order to do those timeouts. So why don't we take a look at a demo that illustrates some of the features of Istio with regard to resiliency. So let's take a look at some of the features, some of the resiliency features, one from each angle, one from the angle of how do I test my app, and then another one from how do I actually do something like implement retry logic. So to that end, I've got another app that's out here running. It's a very simple app. You can see that I've got from the deployments, I've deployed out a version 1 of my web. And then I've deployed 2 versions of my API. So each of these things, the web app just calls into the API. The API returns what host name it's running on. The web returns its host name and then also concatenates that to the API's host name. And we can see what this looks like. I've deployed out an ingress controller here as well. So we can see what this looks like by running it inside of a browser. And so we can get to this, and if I just do Control R and just keep refreshing this, you can see we're toggling between version 1 and version 2. Now earlier we saw how we can use routing to control that, but that's not the purpose here. We're going to version 1 and version 2. Now what I want to do is the first thing I want to show you is I want to inject a fault. And so I'm going to go ahead and let's take a look at what this might look like. So I'm going to inject a fault into my version 2 service. And so my version 2 service, 50% of the time, I'm going to inject a 400 fault. So let's go ahead, and this just illustrates how we're able to test our application and see what it does when that fault occurs. So let's go ahead and try this thing. Let's go ahead and go out and let's do our route inject fault. And then we can go back and see exactly what that's going to look like for our application. So let's go Control R. And 50% of the time we're going to see we get this fault filter abort. It's actually throwing a 400. If we called the service itself, we'd see that there was a 400. Well, this isn't actually what we want. We would probably want to make sure that we're trying retries and handling any failures that may occur. So Istio has given us the ability to test and see what happens when our service does that, and now we know that our application doesn't behave properly, and we would likely go back and fix that. Now, well, let's go ahead and create that. The next thing I want to do is I want to illustrate to you how we can do something like do retries upon faults. And so what I've got is I've got another service another version of the API service that I wrote. It's version 3. So let's go ahead and deploy that. So we're going to do a k create -f, and we'll do route. We'll do return hostname version 3, and then I'll show you what that looks like. And if we take a look at our hostname version 3, you can see it's just calling out version 3. And then in this case, what we're doing here is we're passing an environment variable telling it, hey, 25% of the time, I want you to throw an error. And so actually inside of the code itself in version 3, you can see I'm reading that environment variable, and then I'm just basically going to throw a 400 if the random number I pull is below or equal to that. So basically we're going to throw an error 25% of the time now. So I've deployed out this service version 3. We should go between versions 1, 2, and 3, and we'll see what happens within our service. So let's go and back to our browser, and let's just go ahead and see we've got some problems here. One thing that I probably did wrong is I deployed that without without injecting my sidecar. So I'm just going to do a k delete -f return hostname version 3, and I'm going to redeploy that with my sidecar. So let's do k create -f, and then we'll do Istio cuddle cube inject -f, and now we should see something a little bit different here. If we go back into the browser and we just do a bunch of refreshes, we're on version 1, version 2, version 1, version 2, And you can see version 3, we're getting this internal server error. And so that's the error that we don't want to see when we're hitting that version 3. So we can go around and we would see, yeah, version 3 is working some of the time, but then other times it's just going to fail outright and we're going to get that internal server error. So we know that we know that services are going to fail like this. So how can we take advantage of Istio's retry logic in order to handle that? Well, we can go ahead and again, we can do a retry policy. So you can see here that I'm basically setting up for, if the destination is return hostname API, I want to route you to version 3, and I want to have a very simple retry policy, and we're going to attempt 3 times in order to when we get an error. So let's deploy this and see what happens. Now if we go back into our browser and we take a look, you can see, I'm going to go ahead and just continually refresh this. We told it to go to version 3 every time, but we're not going to see any failures because behind the scenes, we're actually Istio, the sidecar, the proxy is actually doing retries. Whenever we get an error back, it's going to go ahead and retry that. And we're able to add that resiliency into our application. So really, we've just hit the very tip of the iceberg on things you can take advantage of from a resiliency standpoint and policy management. And hopefully you've seen the power of what we can do in Istio. Let's go back to the slides and take a look at the last feature we want to talk about, which is monitoring. The last set of Istio features to discuss has to do with visibility. And so because all of the traffic flows through these Envoy proxies, we're able to do things like be able to handle distributed tracing, and we can collect metrics and logs, and we can query via Prometheus. We can set up custom queries. We can also, within our services, we can expose custom data to Prometheus, and then we can visualize all that via Grafana, and all of these are easily installed. The other really nice thing is Istio creates a really nice dashboard for you when you install it. So let's go ahead and take a look and see what we get kind of out of the box from a tracing and monitoring perspective. The last thing I want to do is show you some of the other tools that got installed when we installed Istio, including Prometheus, Grafana, as well as Zipkin. So you can see here, if I look in the Istio system, the pods that are running, we've got Zipkin, Prometheus, and Grafana. So Prometheus is the monitoring and time series database. Grafana allows us to visualize that, and Zipkin is our tracing utility. So those are all running. And if we do a get services, let's just do this. You can see that we have these things that are running as cluster IP, so I haven't exposed them from an external IP perspective. I could do that, but I haven't done that. So what I actually did do is I just used port forwarding so that I can reach those on localhost on my local machine. So up here you can see I'm able to get to Grafana over port 3000 on my local machine, and port forwarding so I can get to Zipkin on port 9411 on my local machine. So what we can do is we can just open up localhost, go to localhost 3000, and we'll get to Grafana that's running inside of our cluster. So this should illustrate, what we're going to get from a monitoring perspective and a monitoring visualization. So I'm going to go to the Istio dashboard, and we can actually go down and start looking through here, and you'll see that we get a lot of information just by default without customizing this at all. And I'll kind of show you a couple of the examples. I'm going to skip over some of the book info stuff, and I'm going to go back down to our return hostname. So if we take a look at return hostname API, and then we've got return hostname web. Take a look at the API here, and so we don't have any data flowing in through here yet. But if I were to flow in through here and just let's just go ahead and hit this several times, we can run through it, I don't know, maybe 20 times or so. If we go back and again look in Grafana, we're refreshing every 5 seconds. We're going to start seeing a lot of the information that we need. So we're going to be able to see that we've got success rate by source and version. Now, because for our API, we're only hitting version 3, we're only going to see version 3 out there, but you're going to see that we have about a 75% success rate. And so that matches kind of what we know. But if we go back down to our web, we can see we're at 100% success rate because the web isn't having any failures because we've handled those challenges that we had. So we can see what our success rate is, we can see what our response time is, and our response size. So we're able to really look at things like the network and how much network bandwidth they're using up. We're seeing how responsive our services are, and we're seeing how successful our services are, and as well as the number of requests. So we get a lot of high-level information, and obviously you're able to customize this. You can very easily go into your service and expose data directly to Prometheus and then visualize it in Grafana. So if you have custom metrics you want, you can expose those as well. Let's take a look at Zipkin and see what we get from a tracing perspective. So let's go to localhost 9411 and see what we've got. Now, the first thing we can do is we can take a look at basically our service graph. So we can see for Istio, we get Istio ingress sits in front of return hostname web, which then calls into return hostname API. From our product page, we're calling into details as well as reviews. That's calling into ratings. And if we click on these things, we can actually see who's using what. But the more interesting bits is actually going into traces. So if I wanted to go and take a look at maybe the product page for our book info calls, we can actually go back and maybe let's just take a look at I don't know, 30 of them, and let's go ahead and find some traces. Now I'm looking at the longest ones first. So this one took 100 milliseconds. We can actually jump into this thing and see which one of our services is taking the longest amount of time. So the product page took 111, details took 5 milliseconds. The reviews took 85, and of that, 10 seconds was the ratings default. So this is the one, if we wanted to eke out any performance, we would probably start looking at our reviews. Now, if we go back here and take a look, maybe instead of the product page, maybe if we look at the return hostname web, we can look at those traces, and we can see, oh, wow, now we can see here we got an error, and we can walk through and see what the errors were. Now, I didn't propagate all the required headers in order to tie all my services together from in the return host name, so we don't get to see the full service graph here like we did in book info. But you can see that we're able to maybe hunt down some of the issues that we had, some of the errors, and be able to trace through and going back to book info. You can see because we used ingress. So let's go back to our product page. Because we used the ingress, we can actually go back. In fact, if I just go back and take a look at, let's see, Istio ingress here and find these traces, you can see from Istio ingress, here are the calls to return host name. But if we were to search to, let's do oldest first, and see that we've got calls down to, maybe we want to go back to 3 hours oldest first. I'm trying to find one of the Istio ingress that's sitting in front of the calls to book info. So let's go to 1,000 of these and oldest first. And hopefully we'll see, here we go. Here's one sitting in front of the product page, and you can see the call directly all the way back from our Istio ingress. All the way from Istio ingress, all the way on down to all of the services that we're calling in, and that's one of the benefits of using Istio ingress. There are obviously others, such as things where you can do SSL termination in there, and they're as well as advanced routing. So hopefully this gives you a high-level view of what you get from a monitoring perspective, just fresh out of the box when installing Istio. I hope this short video has been helpful to you to understand, A, why you would care about Istio, as well as taking a high-level look at a lot of the features that Istio provides to you, and why you might want to take advantage of a service mesh such as Istio in order to add things like visibility, resiliency, and to save time for your developers, make them much more productive, and as well as the security features that allow you to move towards a kind of a zero trust network with the ability to have mutual TLS, to have identity for each of your services, as well as to be able to manipulate things like Calico network policy, which is coming very soon. So hopefully you've got a good feel for why you care about Istio and just how easy it is to use. If you have any questions, feel free to reach out to me. My email is rob.bagby@microsoft.com.